Hello my friends, my name is Nikolai and today we will look on my second board and also we'll check if opto-couplers can solve EMI problems. Let's get started. So this is my first board. Review of this board I believe uploaded on this channel and you also can find it on GitHub. And this is my second board. And as you can see, there's quite a difference. First difference, there are some parts moving around, but more noticeable, here one diode for this DC-DC regulator. It was tiny and now it's a little bit bigger. Also, this old board contains linear power regulator, and this one doesn't. It's just empty spot for this because it has DC-DC power converter. Because in case 5 volts uses for sensors, it may overload this power converter, and DC-DC can provide more current and it also heats up less. Also, there one more IC there. It is RS485 transceiver, which mean in theory you should be able to connect Modbus spindle to this board. This part is unchanged. It's basically packed a little bit smaller footprint. And also there one more diode here. It's the same diode as grblHAL has. On grblHAL it's for prevent 5 volts applied to the pin go to USB, and this diode basically does the same thing. So it's prevent 3.3 volts go to this regulator if it's and it's basically does the same thing. It's prevent 5 volts from USB go through to this regulator if it's not powered. And there are also opto-couplers that placed inside grblHAL. There are also quite more settings. Let's check it out. So those two, it's selector for what power should be used. If you apply 12 volts here, then this one should be flipped to 12 to power. So it basically tells that this will go directly on 12 volts rail. And if you by some reason need more than 12 volts, like I plan to power it at 48 volts from my main power supply, then it should be flipped in regulator position. Why there are two and there's just one? Because on this board, this jumper selects between this connector and output of this regulator, and on this one it's same jumper here, and this jumper disconnects input on this regulator when it's flipped in power connection. So it's basically to remove power from this regulator if it's unused. The next one is selector 5 or 12 volts for outputs. All that marked plus V is selected by this jumper. The next jumpers enable mist, flood, spindle enable, DIR and PWM is selection between push-pull, which basically 0 and 5 volts from this IC, or open drain or open collector from ULN 2003. And those black one is a selector, interface selector between enable DIR and speed for spindle and RS485 for Modbus. When those flipped in bottom position, it's enabled DIR speed, and when it's flipped in upper position, it's RS485 from this IC. So enable and DIR become A and B for RS485. And the last part is those opto-couplers. So people on Reddit told me that this solution will not work. It will be susceptible to EMI, and I didn't have any problems until recently, but we will talk about later. And we also will see if optocouplers can solve these problems. So basically those optocouplers, one side is on microcontroller input side. It's all really short, so it shouldn't be susceptible to interference. Another side is LED, and it connected to wherever voltage is selected here and goes through this resistor. And those resistors selected to provide about 20 milliamps on LED at 12 volts and 7 milliamps at 5 volts. So should work just fine. Yeah, and those couple jumpers is selection between 5-axis or programming interface for developers, because it's basically uses same pins here. That's it. Now let's check problems and see if those optocouplers can solve them. And there is a problem. I'm trying to measure the center of this hole, but as you can see, it doesn't do it. It just tries to move in one side and then move another. It looks like sensor is triggering immediately, but interesting thing, it doesn't show in IO sender. And command to start probing executes without an error. And now let's open the controller, turn on oscilloscope, and let's try to figure out what is going on there. Probes got ground connected to controller ground via small wire, and controller ground also connected to capacitors. It's because I have another power supply for controller, and to make ground equal, I connected it with a wire, and this is a ground level. And as you can see, there are quite a lot of interference, and it's just this small piece of wire acts as antenna. And this is a probe input on controller. Now we can take a second probe and try to look on stepper driver output. As we can see, it's basically match those interference. We can also look on output from other drivers. It's a smaller one that I use for X and Y. And as you can see, it's same thing, but the interference is smaller. Let's have a look on a microcontroller input. And as you can see, the interference peak to peak is about 2 volts. And if I touch the probe, it goes up, which means I found input correctly. First power on of new controller, and no magic smoke, which is good since it's powered from 48 volts power supply. Now let's try to run center finding again, and looks like it's working. No any unexpected probe triggering. Now let's have a look on controller input before optocoupler. As we can see, interference even higher now. It's like 3.3 volts. Now let's have a look on microcontroller side after optocoupler. I have to find this input. Yeah, look, this one looks correctly. Here, as we can see, interference a little bit smaller, 1.4, 1.3 volts. So, conclusion. Optocouplers did solve this problem, and I guess I was wrong and I should place opto-couplers in first place. But now, why it happens? If you paid attention to those oscillograms, you probably should notice that when sensor not engaged, it's not quite at zero level. If you look on micro side with opto-couplers, when sensor engaged, it at zero level, and when I touch it, it jumps higher, like 3.3. And on old controller, it doesn't happen. And it doesn't happen because inside this guy has 330 ohm resistor on output to prevent shorts. So if you accidentally connect it to power and sensor is trying to output ground, nothing happens because it limits current. However, I used 1 kilo ohm resistors to pull up micro inputs, and this resistor combined with this resistor makes a voltage divider, and basically zero level equal 1 volts instead 0 volts. And on top of that, when we added interference, we got some triggering. With opto-couplers it didn't happen because opto-couplers need turn on LED inside, and additional 330 ohm resistor lowers current a little bit, but not enough to prevent opto-couplers from triggering. So I guess that's it, and I'm happy it works. And I connected 2 sensors in parallel. I can use either one. So that's it for today. Thanks for watching and see you next time.